All right, a little bit about us. We make all sorts of management packs for System Center Operations Manager. Our best known products are Oracle and VMware Management Pack, and perhaps you've heard of the Ping MP. Our very first MP was the BlackBerry Management Pack, which is still around today, but of course much less popular. Our BlackBerry Management Pack meant that all of our first customers were specifically financial and legal enterprises, as well as government and military organizations. And these in turn would often request on-site customizations with infrastructure connectors and our collectors, allowing us to further our know-how and of our knowledge base. Established in 2011, then we established direct lines with the Microsoft System Center product team, and I've been an alliance partner ever since. So that includes, of course, with the cloud and the PACE technologies, the cloud technologies. We're in this webcast with Approved Consulting as a European IT integration company, which is based out of Gothenburg, has over 20 years of consulting experience in monitoring and in ITSM, both, of course. We've worked very happily together with each other on several projects since 2015, including one where we had a collaborative approach to capacity planning and analysis. And today we'll be showcasing our latest collaboration, with the subject being, of course, IT automation.
So basically, my name is Vincent de Vries, and I'll give you this introduction. So what is machine learning? Well, from the internet, I grabbed a definition, and mind you, there are multiple definitions of machine learning. But in this case, machine learning is an application of artificial intelligence, AI, that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. So that's actually a really great thing, because what we can actually do now is start to program machines with people who have a lot of experience in a particular field, maybe finance or maybe something like manufacturing, without actually having or needing knowledge of developing language or programming language or such. So we can use their knowledge and actually encapsulate this in a program. Now, machine learning, the basics of machine learning is nothing much more than really statistical analysis of the world. And as you can see in this very tiny diagram, you can hardly make out, basically what it says, but it doesn't really matter. Machine learning has a couple of families of algorithms, and you can see these. They're like deep learning, ensemble neural networks, other things. So, but yeah, in essence, what I want to show you here is that machine learning is nothing more than a couple of equations which are in different forms. So let me give you some examples of machine learning. One of the most common ones is regression. So regression we can use in the financial world to do predictions about the world, but we can also do it for something like frozen yogurt. So we know that if you have a low temperature, that you're probably going to sell less frozen yogurt, but if the temperature is high and it's summer, then people will want to eat a lot more, and you'll sell a lot more frozen yogurt. And so we can see that in this green line. Now, if we have a particular temperature, then we can start predicting the amount of frozen yogurt we'll sell. The same thing is for classifying things, basically saying, oh, is it going to be an apple or an orange if we have it in a particular classification. And what we can see on the graph is that on the left-hand side, we have apples, and we can see all the red crosses. And if we correlate these in size and color, then on the right-hand side, we can see oranges, and they're pretty much all on the right-hand side of the graph. Now, what would happen if we would actually draw a blue X here, and we wondered what it was going to be? Well, most likely it's going to be orange because it's already on the right side of the color spectrum. Now, we can also do collaboration-based filtering, which is basically people, they give them their preference. And if somebody has a preference and they make it known, then for example with movies, Netflix is a good example, that Ted likes movie A, B, and C, and he gives a score to that. Carol also likes movie B and C, or she's seen movie B and C, and she scores them as well. Now Bob has only seen movie B, so what is the likelihood that he's going to like movie C if he's already seen B, and Ted and Carol also seem to like that. So most likely it's going to be a 5. I won't get into the specifics here, why that is, but this is a collaboration-based filtering model, and you can also calculate the probability that somebody is actually going to like a particular movie if other people like it. Now, one of the most popular and most well-known forms of machine learning these days is neural networks. And neural networks have been around for quite a long time already, since basically since the 60s, 70s, when postal services started using them for handwriting recognition. So they didn't have or didn't really need people anymore to sort the mail, but they could do this by machines. And neural networks were a good application of this. Now we have different categories of machine learning, and let me quickly go by them. First, we have supervised learning, we have unsupervised learning, and we have reinforcement learning. Now the first two categories, they're kind of tightly tied in with each other. So on the right-hand side, you have supervised learning. And basically what we do with supervised learning is we tell the machine or the algorithm what kind of classification our data has. So as you can see here, we have red crosses here on the upper side, and we have circles here lower left side. Now, if we tell the machine in advance where these data points are on the graph and what type they are, so if they're a circle or a cross, then we can start creating an algorithm for that and telling the machine what is going to happen. On the other side, we don't tell the machine what kind of data it is, so we don't classify it in advance, and we ask our algorithm to start specifying or to start correlating the data on its own, and then basically tell us where the clusters of data is. So these are two different approaches, and they all basically they have their own usage. Well, unsupervised learning would basically be used when you have no idea what the data would be. To move on, we have reinforcement learning. This is basically telling our machine if it made a bad or a good decision. And if it made a bad decision, it could be something like a -1, so we deduct something from the score. And if it was a good decision, we could do something like +1, and we add to the score. And in this way, we tell the machine, hey, you know, the decision you made was correct, or the decision you made was incorrect. Now, what about neural networks and deep learning? Well, you know, they are pretty much buzzwords these days, so let me just quickly go into them. First of all, neural networks can be used to tackle all three types of machine learning, the categories we just talked about. But they're not always the best solution to tackle these problems because they might be slower or maybe less accurate. So it's basically your Swiss Army knife for tackling problems, but it might not always be the best solution. Well, if we talk about neural networks, they're basically the same as neurons in our brain, and they work accordingly. So I'm showing you some nice pictures of how we actually, how our brains work, and they're kind of the same shape if we look at machine learning. So basically what we do with a neuron is we have input neurons, so we have X1, 2, and 3, and we have neuron B. Now X1, 2, and 3 are inputs to neuron B, and if the inputs of these X neurons are strong enough into B, then the output Y will be fired, so basically it will be a 1, and if it's not fired, it will be a 0. So that's basically how a neuron works. We can excuse me. I think I missed one slide. That's basically how our neurons work in machine learning, and basically also in our brain. I just wanted to give you a quick overview of machine learning and neural networks in this way. So what can machine learning do for us? Well, basically, we would like to give you a practical example. And at this point, I would actually like to invite Jonas, who is going to do a demonstration for us.
So as Mark and Vincent mentioned before, we have worked closely with Opslogics to try and solve some of the challenges that we are facing today at with the clients that we work with in the projects when it comes to escalations and integrations with the ticketing systems. And before we go into the demo, I would just like to give you a short overview and getting us all on the same page where we are today. So in the world now, it's getting more and more complex with how the alerting needs to be routed into different teams. You might have a situation where every alert from the different management packs is being escalated or routed to each technology owner. It could be to the web operations team for all alerts related to the IAS management pack. We can have the SQL being escalated to the database operations and so on. But what we see more and more is that actually we're getting the IT operations team, the first line, to deal with the alerts for at the first stage and then being escalated over to the different teams when they're not able to solve. But in the more complex world, we are also seeing that more and more the alerts are being handled by both tiers, that we can actually get the first line operation having to deal with the critical alerts, and the warnings and informational alerts are being distributed to the second and third line tier directly. And with the rise of the DevOps and the isolated teams, we also see a lot of scenarios when different teams wants to manage their whole stack of alerts in conjunction with the other approach, where some teams want to deal with some of the layers and the other ones want to have it the old traditional way. So the whole scenario on how these alerts are being distributed to different teams within the organization is getting more and more complex, and this is something that we see every day. And this is why we had the discussion with OpsLogix and try to see how we could, with modern technology, solve this issue. And that's the use of why we are working with Easy Alert. So to start with, if we look at the previous picture and how can we actually have machine learning to do this job for us instead. So I'm going to switch over to our demo environment. So here we can actually see that it's probably pretty empty, and hopefully this is something that it looks like in your environment. But if we move over to the Easy Alert interface, we can see that we have a lot of alerts that have been pushed in from the connector in Operation Manager. In this view, we can actually set and train the alerts on where these should be distributed based on the different information in the alert. So it's actually using most of the attributes within an alert to calculate the probability of where this alert should be escalated. So if we have some of the alerts here, like the elastic one, and we can actually see that it's red because it's underneath the threshold that we have configured, we can train this alert to go into a resolution state. And now it's pushing in the alerts. And you can see now that we are getting more and more alerts, and it's actually predicting that these different alerts are going into different resolution states, and these alerts are then being escalated, maybe through an ServiceNow connector or Service Manager, but all of these are actually being calculated based on the information within the alert. As I mentioned before in the previous scenario, we get a lot of more complex situation where different teams might want to end up managing the same alerts from the same management pack, but it's being based out of different information from the infrastructure layer. So we can actually take into consideration and try to populate more information about the infrastructure that we have. So in this scenario, we're actually populating information about the infrastructure, like the operated by different purposes and all other information that we could actually use. And if we take a look at the alerts and go into EasyAlert, we can set up actions. So we have something called pre-actions here. So what we do here is to work with something that we call alert enrichment. We are pulling out the alert and we are populating it with different information that we would like to use to be able to increase the scoring of the machine learning algorithms. So to start with, we are populating custom field here with the management pack that's actually generating the alert. And also we have a different one that is populating the different classification tables that we have, like the operated by, the environment status, and so on. And these actions are being executed before the machine learning algorithm works with the alert, so we can actually take use of all this information to better determine where these alerts should be routed. So if we take a look into some of the trained alerts we have today, so we have the elastic alert, and we can see in the token that these are the things that it's getting into or taken into consideration when doing this decision where the alert should be handled. And we can also set up a threshold to say that if the scoring or the probability is not above a certain percentage, it should not set this action to actually put it into a different resolution state. So if the machine is not certain where this alert should be routed, it should leave it as is, and for you to actually train the alert a little bit better until it reaches this threshold. And after we have done this training for the alert, we can actually configure post actions. So this could be that we could, when an alert is being transferred into one resolution state for this, like in this case database operations, it could configure a custom field that we could use for statistical purpose, or we can actually have an email sent based on which resolution state it ends up in. And for the statistics, it's really good because when we're working with automation, we are actually doing a lot of work behind the scenes, and this means that we need to, in some way, actually find how much improvement we actually did when doing this type of automation to be able to show the efforts and time that we saved with this type of automation.